here to talk to you a little bit about today is the Aerospike database. Aerospike is a high-performance, NoSQL, ACID-compliant database. What that means is people like the third largest brokerage house in the US trades on us, uses us for a trading platform every day. 150 billion transactions a day. That's 5.5 million a second Aerospike powers. If you do any get betting on DraftKings, something like that, we support them as well. We are the back-end engine to those databases, or to those systems, excuse me. One of the key features of Aerospike is a patented technology called hybrid memory architecture. What the hybrid memory architecture does is allow you to have high throughput with a small footprint. Companies like PayPal reduced their systems from roughly 1,200 compute clusters down to 60 using the Aerospike environment. What that does is give you more value and gives you much more data throughput capabilities in the platform. I've got 20 minutes to go through two different demonstrations, so I'm going to skip through a fair amount of information in the background and try to give you some of the salient points here. What I'm doing right now is showing you on AWS an Aerospike instance running on 8 nodes. They're 8x, I4, 8x larges if you care to know about that, with 16 client users. They're running roughly 150 threads each client against the database. What's interesting about that, though, is this really boring slide, or really boring graphic here, because it just runs smoothly. It doesn't fail. It continues to operate. What I'm seeing on the left side of the page here is the read rates of the Aerospike platform. It's running at about 834,000 a second right now. It's writing at the same time. It's running right about 449,000 a second simultaneously. One of the unique features of Aerospike is that it can read and write simultaneously at high throughput rates. That's why we're used at the brokerage houses, why we're used at PayPal, we're used at other different services, because we have high performance read and write capabilities of the platform. Now, you may think that's all fine and good, you're doing all those writes very quickly. How's my latencies? Sub-millisecond. Nothing unusual about that, is there? Yeah, it's very unusual. All Aerospike's read and write latencies are running under a millisecond right now. 99.9% of them are running under a millisecond. I've got roughly, let's go here, we get the right page here, 964 million records in this database. I loaded it up this morning. It took about 45 minutes to load that many records. Pretty quick, pretty easy to operate, pretty functional. One of the nice things about Aerospike is that I really don't have to do much work for it, even if there's a failure. I'm going to cause that to happen right now. I'm going to drop over here. I'm going to stop this. What I've just done is I've taken out 2 nodes of my cluster. I've reduced it by a quarter. 25% of my workforce or my workload is being diverted to 6 nodes now. You notice I got a little split on screen. Got 8 and a 6 there, and the migrations are starting to happen. That's that red box on the left side of the page. What it's doing, though, is rebalancing itself automatically. We're resilient. Aerospike is designed to know that failures are going to happen on compute platforms. So we've designed the product to be resilient when that particular type of actions happen. And what it's doing right now, you'll see a little bump in my performance. I've just lost, if I was driving a car, I lost 2 cylinders of my 8-cylinder car. All of a sudden I'm running on 6 cylinders, but I'm still running. More importantly, you'll see it drop off a little bit, and then it'll come right back up once it rebalances out. The instance that it notices a failure via a heartbeat automatically starts to repartition the data so that I don't have any failures. You'll note on the reads, I'm doing 100%, not a failure on a read. I'm getting a few timeouts because I lost some nodes. I was connected to this node, and all of a sudden it's gone. I get a timeout, I kind of expected, but I only had 15 when I'm doing 1 million plus transactions a second. I'll take that. That's not a bad situation. But it's rebalancing itself out. Workload is coming back up, as you noticed, dropped down to about 744,000. Now it's back up to 838,000 reads a second without any glitches. I had no IT involvement. Nobody had to go in and reconfigure the environment. Nobody touched it. I just turned off a couple of nodes, and Aerospike automatically rebalances itself back out, delivering that high performance throughput. Again, I see some migrations happening because I am moving data around. I've always got a second copy of Aerospike as well, by the way. One thing I didn't mention earlier, I've got 2 copies of data all the time, so that if I do have a failure, I can read it from my replica copy or from my primary copy if I lost the replica set. Continues running, no hiccups, just continues to operate properly. Let me put that node back in, those nodes back in, and We start them here, and you'll see it rebalance itself back out. But that's the power of Aerospike. We power all sorts of, if you saw Srini's speech a little while ago, we power all sorts of different applications. A lot of financial institutions use 60% of the financial institutions in the world use Aerospike as the database of record. A lot of different configurations that are designed for that kind of work. I can go through all sorts of different pieces here. And I've gotten 5 minutes in. We're doing pretty good on time so far. So let me take a look here. My namespace. Namespaces are how we store data in Aerospike. It's a logical location for data to be stored. We physically configure it for a particular device setup. One of the things we can do, which is unusual for a lot of platforms, is that we can run in 3 different modes. I mentioned the hybrid memory mode a little while ago. We can also run it in full in-memory, hybrid mode, and then all on SSD. Now, one of the things that is unique about that is that hybrid memory mode is a patented technology at Aerospike. Nobody else can do it. What it means is I have data in memory, my key in memory, and I have my data on an SSD. Now, we don't just use it as an SSD like you would like a file system. We actually have a proprietary technology that uses it like a raw device, if you're familiar with that kind of terminology. There's no file system on it. We own the IOs to that particular device. We do all the work on it, so we know exactly where data is. We get it in what we call a one hop to data. When the client knows where my data is on my cluster, when the client requests that content, it goes to that one node, grabs the content, gets the data, and delivers it. Sub-millisecond response times. That's a unique features of some of the unique features of the Aerospike database. This is going to continue to run for a little while, by the way, to get it rebalanced out. But that said, when I do that kind of work, I notice there's a warning here. Well, that's interesting. Why is that warning up? It's because I'm rebalancing my cluster out. Let's take a look here real quick. Down here, the lower portion of it, I got a little latency problems going up. They've actually gone up probably to, oh goodness, we've had a couple of them that went out a little out of bounds. I lost some nodes. I'm putting some nodes back in. It's doing pretty good, in my opinion. No downtime. Again, no very low latency delivery of content in the database. Still balancing out a little bit here. So that hybrid architecture, though, allows me to put that data on SSD. What that means is I can make my devices, my nodes, extremely dense with content. So I can get that reduction that PayPal saw down to roughly 60 nodes in the Aerospike environment. Roughly, the different central banks are using Aerospike with substantially less hardware than they used to have to require for those deliveries. We are a very reliable, high-performant, again, database. Now, I've talked a little bit about the Aerospike database itself, but you guys are here for something more important. That's fraud detection. And what we're going to do here is show you a little bit of work on that fraud side. So we want to detect fraud. We don't want to have any of that happen to us in any particular instance, but it happens. I've got a new credit card once a while ago, and I used it someplace that was relatively unusual, Home Depot. Weird to get a flag there, but it flagged me. It gave me a little text saying, hey, is this you making this particular purchase? And I said, of course it is, and so it went on through. But fraud is a big deal. For instance, PayPal uses Aerospike for their fraud detection. Before Aerospike came in, there was roughly 98.5% of the transactions were fraud detected. They weren't fraudulent necessarily, but fraud detected. But they had to go through about 1.5% of their transactions because they had an SLA to meet. If they missed that SLA, they let the transaction go through. Oftentimes that led into fair amounts of payments that were fraudulent to different vendors or different people, and they were losing roughly $5 million a day in fraudulent activity. Aerospike came in, reduced that window, that SLA, to 99.95%, leaving them roughly $110,000 a day in fraudulent activity. We paid for ourselves in a day. That's the kind of capabilities that Aerospike provides. That facility is done through using the Aerospike graph capabilities. I've got a limited version here that I've set up, that I've configured for our demonstration, but we're showing our graph capabilities. How many out there are familiar with graph? Can you raise a hand? So I give a little bit of information about a graph. Okay, what graph is a relationship of data without predefining a relationship. So I've got a person and devices, computers, their account numbers, potentially account information. Then they have another person over here, and there's a relationship between them. That relationship can be dynamic. It can be defined any way that you wish. The idea is that if I've got person A, person B, and person C. Person A is an innocent bystander, if you will, an innocent transaction maker. Person B is a little potentially crooked. And then person C is actually the criminal. So if I do a transaction with A to B, I can see the potential that that might be a legitimate transaction. Then B goes to C, then all of a sudden I know that's a fraudulent transaction. That's kind of information that a graph will give you. It gives you a lot more than that. That's a real basic definition of or a description of how the graph operations. What I've got is a cluster or a node that I've built up. It's got roughly 10,000 users. This is all pre-generated data, so it's bogus data, but it's pre-generated for me to work with. I've got roughly 10,000 users. I'm not running any transactions right now. What I'm going to jump into is a little bit about our fraud detection capabilities right now. And this is using a risk model that is, and this is as well just made up, make it functional, but it's a risk model that tells me different various levels of risk for a particular person. Under 25% or a score of 25, there's no risk. Between 25 and 70, medium to high risk. And then over 75, or 70, excuse me, is a very high risk situation. The idea of this is I can have different configurations where I have some scenarios here in Aerospike. You can have as many of these as you wish. These are some samples that we've got built up. One is the transaction flagged, transactions account is flagged. One is the device is flagged. And then there's the association of different pieces of information. The association is the critical factor because by definition, or not by definition, but by implication, if I have a transaction with something that's legitimate, I'm not going to worry about it. But if I go to another space where that is illegitimate, I would want to know that kind of information. That's what the hops do. So what a hop is one node to a next node to a next node. This can get really expensive because there can be billions of nodes. Aerospike graph, an Aerospike database is designed to handle, if you're familiar with graph databases at all, 30 billion edges and vertices. Billion. Most of our competitors are in the hundreds of thousands. Very large configuration, very massive capabilities in the Aerospike environment. These are, again, the different transactions that can happen here. What I'm going to do is turn some on. I'm going to run it at 200. What I've got now is transactions going through. You can see them building up here, 300, 500, 700, and so on, of the transactions happening. These are people sending money, either a credit card, savings account, checking account, moving money around in the different environments. And as I mentioned, a lot of the central banks use Aerospike as that transactional database. We've got some transactions that are happening. There's 3,200 now that have happened so far. Let me refresh of this page. I'll see some more going on. They continue to go through. Notice that there are some getting flagged here. Okay, this one is blocked. This one's clear. Let's take a look at it real quick here. Look into this particular transaction that's going on. And this is going from Victoria McLean to Brian Watkins. Looks all good, fine and good. There's no fraudulent information in there. But if I go back and take a look at one that is actually a fraud, for instance, this one that is blocked, take a look into it. I notice that the risk assessment's at 100. Obviously, that's a fraudulent transaction it's attempting to go through here. And what's fraudulent about it? Well, we go in and find out we triggered out some of our different flags that came in. Remember I mentioned that we've got these 3 different flags. Those 3 different flags are what's detecting potential fraudulent activity or, in fact, fraudulent activity. And what happened in this particular one, it triggered off this account number. The sender has a fraud score already of 100, so they're obviously having some transactional issues or having some problems with their accounts. This could be actual or fictitious. And as well, they triggered another one that has the different accounts that have been flagged from this particular partner as well. Again, a lot of different content that comes out in this. Let me show you a little bit more about this directly. I'm going to stop those transactions right now. I've got 18,000 that we just ran through in those few minutes that I was standing up here talking to you. They're still here, still all available for us to review and look at. But what I'm going to do is I'm going to go ahead and enter some of my own transactions so we can follow these very directly. I've got a couple people up here that I'm going to work with, and pardon me for bouncing around a little bit, but I can't remember the numbers, so I'm going to use them. I'm going to copy and paste them here. I'm going to copy that and go over and Abigail here. She's a veterinarian, and she's transferring some money over to Casey. Casey's a guy that sells some veterinarian supplies. So he seems to be a legitimate business, so she's going to buy some supplies from him, and she's going to transfer that content from her checking, or her savings to his checking. So I'm going to go ahead and enter this here. That's a checking account. I'm going to put in 1,001 so I can determine which transaction I'm looking at when I go over to my transaction page. I run that transaction. So when I have run it, I'm going to take a look here real quick, and I see that transaction happen right here, 1,001, and it flagged it right off the bat. Well, why did it flag that? Well, we take a look at the information about it. I'm going to go ahead and review it. And I see that the account fraud scores at 85, but I see nothing obvious in their account information. But I go to my fraud analytics and I see that it triggered up after 12 bounces, it found a potential problem in this particular account transfer. I can now have a decision to make. This is when you get the phone call saying, hey, this is a potential fraudulent transaction. Get that phone call, said, no, that was me. So Abigail goes, that's fine, let's go ahead and continue that process. We'll be done with it. So I'm going to go back to my admin page here. I'm going to enter another transaction. I'm going to take that one from Casey here. I'm going to copy this properly, or not copy it properly as the case would be. Take that Casey here and put his account number in the sender side. Do that. And he's sending it over to his bogus account under Aaron. I'm going to copy this Aaron's information here. I'm going to put it in here and do that transfer. But he's going to transfer in $2,300 in this particular case. I'm going to go ahead and create that transaction. Now, once I've done that, my rules are going to kick off again. Notice there's my transaction here, $2,300. This is critical as well. Do you have any issues with this one? It looks like it's fraudulent. It has been flagged. Nothing in the accounts directly are inappropriate. But again, that 12 bounces that came through again on this particular transaction. So that might be something I'd be more concerned about. I'm going to, at this point, let this one continue through. I'm going to do another transaction here real quick. And I'm going to use a different account. This is going to be Aaron Bell. And he is going to send some money to Casey as well. Jump over here to the savings account this time as opposed to a checking account, into Casey, and set that savings and do a $3,000 transfer. I'm going to create that transaction again. One more time, jump over to my transaction history, and I see in here there's that $3,000, and it was blocked straight up. Why was it blocked straight up? Because look at that history of that particular account set. He was triggered because he had flagged devices. He's got a flagged accounts and multiple accounts, and he has a receiver credit or fraud score in the 100 range. So he's got a lot of different problems in the background of this particular user. So if I take a little closer look, I can go into excuse me, the wrong page. I'm with the transaction set here and reopen that guy up. And what I can look at is the further account assessments. As we go a little further in here, there's the same set here. Go back to my transactions, and I take a look. I want to take a look at the next set of transactions that we're going to run through here real quick. One more set. We're going to take that savings account one more time. We're going to transfer that out to Aaron here one more time, and see what we get comes through. Paste it in here, and I got that extra space in there. I do that almost every time. And we'll do a $4,000 transaction. We're going to see this one as it comes up. It was critical as well. It was blocked. And I can take a look at that transactional information and see a little bit more about them. Again, we triggered out several different events on this particular group on that particular transaction set. What we've got is a high-performance database managing fraud detection through graph services that allows me to recreate and modify my own particular set of rules so that when I do run transactions in this environment, I can see fraudulent activity based on different relationships of people across different versions or different accounts, different devices, different infrastructure, all sorts of different locations that allow me to do a better diagnosis of a particular transactional problem or issue. With that, hopefully there's a couple of questions out there. Do you have any questions so far? I see none. Sorry. I can't see it all back there, so sorry.
I was curious about how your graph noting is similar to blockchain infrastructure. What's the difference? Or is there any similarities at all?
A blockchain is I will say more secure, although that's not really the appropriate phrase to use. I mean, I actually have a really good answer for that. I know the gentleman over here, Sashwood, though. He's a brilliant man. He's one of our high-end technical folks here. But a blockchain is there's a transaction ID that's established between the different blocks in that particular chain, and however far it happens to go. A graph is a little different in the fact that you're not predefining the relationships. That's one of the biggest values of a graph environment, is I don't have to say, like in a relational database, table A to table B to table C to table D. I can just put in information about table person and have a relationship that can be open-ended. Like, for instance, a person has a phone. That's a definition of a short little graph information. The phone and a person, and they own one, if you will. And a graph, that relationship can be virtually anything that you want. And when I create that kind of relationship, it's dynamically generated at query time. So when I do that particular query, I don't have to previously know the content. I can infer it from the data that I already have. And then in this particular case, you'll notice there's, let me scroll that up a little bit. There was 2 different connections there, but the bottom one's got 13. We went through 13 different evaluation phases to find out that that's potentially a fraudulent transaction without predefining that relationship. Does that help answer your question?
Yes, thank you.
You're welcome.
There's one more.
Right here.
Hi, can you store the graph data alongside the same cluster as the NoSQL?
Well, certainly. So be completely transparent here. The Aerospike graph structure is different than the standard relational or standard data that was inserted into the Aerospike database, but it is in the same cluster. It has the same configuration parameters, the same setup, but it does store it in a different namespace. And the namespace is like a database, if you will, but it stores in a different namespace so that I can query the same cluster for multiple different forms of content. Correct. You're welcome. Any other questions? Well, my time is up. I thank you very much for your time. If you want to take a look, Aerospike is at booth 118 over in the hall. Thank you very much.